Two-way tables are yet another way of just representing data. In these situations, where we've got two different variables we could compare something against. For instance, in the first table, you could be asking people what their favourite flavour of ice cream is, whether it's chocolate, vanilla or strawberry. But then also these people could be broken down into kids and adults. Now, just looking at this kind of scenario, because it's not always given to you straight away in a table, it could just be given as a description. You may be forgiven for thinking this is just like a Venn diagrams question. If you haven't done those yet, I would suggest looking at that video as well. But the key here is, whereas in Venn diagrams, you're basically going to have two things that can happen and they may overlap, maybe a third in some cases. There are too many options here that are related to each other in different ways, and people are only going to exist in distinct groups. So we're going to represent it as a table anyway. As I say, sometimes, as you can see before you here, you may be given a half-complete table already, and you're asked first and foremost just to fill in that table. So here we've got that 18 kids like chocolate and 30 people in total like chocolate, that 3 adults like vanilla, 22 people like strawberry in total, 35 kids were asked this in total, and that 60 people were just asked in total. Filling in the gaps, therefore, because everything has to then equal the total in its row or column, so just in this end column here. If the kids and the adults has to give the total of everyone, the 60, that leaves there being 25 adults, because 35 add 25 is 60. Along the bottom, again, we have to add up to 60. We've got 30, we've got 22, so this here just has to be 8. For this column then, if the total is 8 and this is 3, that leaves 5 kids liking vanilla. For this row, if there's 18 who like chocolate, 5 who like vanilla, and 35 in total, that leaves 12 kids liking strawberry, 22 people like strawberry in total, 12 we just used up, so that's 10 adults. And then finally, whether you're looking at the chocolate column or the adult row, you would find this total here being 12. So now that you've filled in your table, you may additionally just be asked, what is the probability that if out of these 60 people, someone was randomly selected, what's the probability that they are an adult who likes chocolate? Well, the adults who like chocolate, that's this box here, the 12. So that'll be 12 out of 60. And if they ask for this in the simplest form, they don't always, but if they did, you just divide, well, you can divide through by a common factor of 12 here. So that would just be 1 over 5. So out of the 60 people, 1/5 of them were adults who like chocolate. And that pretty much is it. As I say, they could give you all the details in statements rather than in a table already. And we'll get onto that when we do the actual exam practice question after this. But for the table side of things, you'll have some numbers in there, whether you're writing them in yourself or they're already printed for you. And then you'll just be filling in the other gaps. Just compare, okay, compared to a total, what does the missing bit have to be? Compared to the total, what does the missing bit have to be? Once it's filled in, if you need a probability, just find the box that matches that description, or boxes, if there's like an or. Like if we'd asked for a kid or an adult that likes chocolate, well actually then that just would have been the 30 out of 60, so that would have been, again, a half. But again, if it's or, you can add them together, is specifically adding. And then yeah. So if we're happy with that, let's have a go at a question for yourselves. We're going to have some different variables this time. Let's say what pets people have. So these people have a cat, these people have a dog, and these people have a rabbit. And these people then in the rows are going to be only children. And then the second row are people who have siblings. Then, as always with these tables, the rows and the columns at the extremes, at the far ends, are just the totals. Now, first of all, using these numbers that are already given, I'd like you to fill in the rest of the gaps and then work out what's the probability that a randomly selected person from the people who are represented in this table, what's the probability that they firstly have siblings and own a rabbit. If you just want to pause the video there and have a go with this yourself, you may want to draw out the table on your own piece of paper, and then when you're ready, just press play again and we can compare. Alright, so there's a couple of different places you could start. For instance, since this here is a total of 50, and we so far have 8 and 18, which give us a total of 26, that leaves 24 for just people who own cats. Now, if 24 people own cats, 9 of whom are only children, that leaves 15 people being siblings having cats. Here, with the dogs, if there are 8 people with dogs in total, 6 of whom are only children, that leaves 2 people having siblings and a dog. The total number of people who are only children, if there are 50 people in total overall, and 21 people have siblings, that leaves 29 people being only children. If 9 people only children have a cat, and 6 only children have dogs, that's 15. 10 people have rabbits, that's going to be 14. And therefore this gap, which yes we could have done before the 14, leaves us with a 4, whether you're looking at the column or the row. What's the probability then of someone having siblings and a rabbit? That is this box here, the 4, so that's 4 out of the total of 50. Now, just before we move on, there's actually just another point I would like to make, which is that it doesn't always have to be out of the total number of people. We could have asked how many people have a rabbit given that they are siblings, or that they have siblings. If it's given something, you are now just looking at that row or that column. In this case, so having a rabbit, given that you're a sibling, we're already looking just at these 21 people now. That's 4 out of 21. Or given that they have a rabbit, what's probability to have siblings? That'd be 4 out of 18. Okay, that's just another thing, just a little bit of wording you want to look out for in these kinds of questions. If we're happy with that though, let's move on to an actual paper question. Now, as I already said ahead of time, this is one that's giving the information in the form of statements rather than giving you a table to start with. I've just drawn out the lines here for efficiency's sake. But we can already see, just reading through this, that there's going to be some variables here with the countries, and then a completely different type of variable here with the people's genders. Because these are such disparate variables, they're going to have to be represented in different rows and columns, so we know it's going to have to be a table. It's probably going to be best if we represent them with a table. With that in mind then, let's just start reading and filling in the details. So 60 people were asked if they prefer to go on holiday in Britain, Spain, or in Italy. So we're going to have Britain, Spain, Italy, and then the total. And we know that total already is going to be at 60. Now 38 of the people were male. So if we just label this here, this is going to be female with a total. And yeah, so total males was 38. 11 of the 32 people who said Britain were female. There's two numbers we're going to plot in here. So of 32 people who said Britain, so 32 people said Britain in total. Of them, 11 were female. 8 males said Italy. And 12 people said Spain in total. One of the females is chosen at random. What is probability that this female said Spain? Well, first of all, we're going to be filling in the rest of the blanks as we have been. So if 32 people said Britain in total and then 11 of them were female, that leaves 21 being men who said Britain. Then 21 add the 8 is going to give you 29. If we need 38 in total, that means 9 men said Spain. If 9 males said Spain and there were 12 people who said Spain in total, that leaves 3 females. If there were 32 people who said Britain, 12 people who said Spain, together that's 44. Therefore, it's going to be another 16 who said, to make Italy to make up that total of 60. If 8 men said Italy, that means 8 women said Italy to make up that 16. And then here, which we could have actually done early on, this is going to be 22 women in total. So then for the probability that it's asking us for, probability that this female is said, Spain. Now we're just looking at the female row therefore, not out of everyone. So it's going to be out of this 22. Now of them, how many said Spain? That's 3. So that would be your answer.